Hello Imran, can you hear me?
Yes, sir.
Okay, let's start. We were doing vectors,
Yes,
right?
sir.
So today we're going to learn vector scalar product, okay, or scalar triple product. Okay,
Yes, sir.
yeah, scalar triple product. What this means is we are going to multiply three vectors, all right, and this will be written as this. Two vectors will be cross multiplied. After that, another vector will be dot multiplied. That is why it is called scalar triple product, because finally we are using dot product, scale product. All right. So in scalar triple product, the final answer will be a scalar quantity, right? Because finally we are doing a scalar thing. All right. This is written as this. All right.
Yes, sir.
Okay. So if there is a vector a1i plus a2j plus a3k, there is a vector b, and this a dot b cross c, you can write it as determinant a1, a2, a3, b1, b2, b3, c1, c2, c3. All right. You can easily solve this and find out the answer. No problem.
Yes, sir.
Okay. This is used to find the volume of parallelepiped. Okay. A parallelepiped is a 3D shaped figure which has 6 parallelogram as its faces. All right. Parallelepiped. 3D version of a parallelogram. You can understand it like this. Okay. Are we clear?
Yes, sir.
Okay. Let's do a few questions. You wrote it down, right? Everything?
Yes, sir.
Okay. Let's do a few questions. A vector, it is given 3i minus j plus 4k. B is given I plus j minus k. C is given. All right. Find B dot C cross A. This is the question. Can you solve it, or do you want me to solve it?
Shall solve it.
Okay, okay. I'll give you 2 minutes.
35.
Yeah, right. Now, can you find A dot B cross C? Please find this also.
$35.
Yeah, right. So if you now find the answer of C dot A cross B, then also you'll get the answer as 35. Okay. What this tells us is if you find A dot B cross C, this is equals to B dot C cross A, and this is equals to C dot A cross B. That means scalar triple product is a cyclic quantity, right? You can do a cycle like this, right? A, B, C. A dot B cross C, B dot C cross A, C dot A cross B. All the values will be same. All right. All right.
Yes, sir.
Yeah. And now please try to find the answer of A dot B cross A in this question only. A dot B cross A.
Is it 0?
Yes, right. So now you can see that if any vector is repeated, no matter where the position of that vector is, if any vector is repeated, then the answer will always be 0 of scalar triple product. All right.
Okay, sir.
Okay. Moving forward, we know that this is used to find the area of parallelepiped, right?
Yes, sir.
Volume of parallelepiped. Now to find the volume of tetrahedron, you just divide it by 6, 1/6, and you will have the answer. All right. All right.
Yes, sir.
Okay. So you can do the first exercise also. After that, straight lines. Do you know the equation of straight line in vector form? This is
No, sir.
write this equation of straight line in vector form, where
What is the first one?
this is R vector, where A is the position vector. Okay, where A is the position vector of a point on the line. Suppose you have to write the equation of a line where this point is on that, and that is parallel to B vector. If they ask you to solve that, a line which is parallel to B vector and passing through this point. So this will be this simple equation. R equals to A, you put the vector form of A position, A point plus lambda times B vector. Okay, lambda is a variable. All right.
So can you read out what you have written?
R vector equals to A vector
The
plus lambda
bottom one.
times B vector is
The,
parallel to
the
R
sentence
vector.
that you have written.
Equation of straight line in vector form, where A vector is the position vector of a point on the line. Okay, and B vector is parallel to R vector. Okay,
So it is where A is the position vector of A
yeah, position
parallel
vector of
to.
a point on the line. Position vector of a point on the line. See, you always need two things to find the equation of the straight line, right? Here, they have given you a point which the line is passing through. Suppose this is 2, 1, 3. This is a point the line is passing through. The line we have to find the equation of, and this line is parallel to B vector. Suppose they say that, and the answer of the question would be 2y plus j plus 3k plus lambda times B vector. Got it? This position vector of this point and lambda times B vector, the vector parallel to the given line. All right. All right.
Yes, sir.
Okay. You can write it like this also. R minus A cross B equals to 0. This is also another form of that same thing. A is the position vector of the point on the line, B is the parallel line, parallel vector. All right.
Is there no lambda in this equation?
No, there is no lambda in this equation. Okay. You can write this as this also. Same thing. All right. We just open the bracket here. All right.
Yes, sir.
You write it down.
Yes, sir.
Okay. Suppose they've given you a question like this. Find the vector equation of the line through the points 1, 2, -1 and 3, -2, 2. Okay. In the form of R minus A cross B. Okay, you don't need to worry about this. See, they have given you two and they are asking find the line vector equation of the line passing through this. So we need two things to find the answer, right? A position of a point on that line and a line parallel to this line, right? You have to find A vector and B vector. Then you will have an answer, right? Are we clear here?
Yes, sir.
So we already have A, right? They have given you 2 points. So you can take any point as A, no issue. How to find B? You can subtract this from this. Suppose this is A, this is B. Then AB you can find like this: 3 minus 1, 2i minus 4j plus 3k. This minus this minus this minus this, right?
Yes, sir.
So this line is parallel to the given line we have to find. So the answer would be this is B vector or B vector, and we already have A vector. You can take this or this. Any one can be A vector. Now put this in this format. R minus A vector you can write in matrix form also. 1, 2, -1 cross B vector also you can write in matrix form. 2, -4, 3. This is your answer. All right. Very easy.
Yes, sir.
No problem.
No, sir.
Okay. See, this is the vector equation of a line. The Cartesian equation is x minus a upon L, y minus b upon m, z minus c upon k, n. All right. These are called direction cosines, but there is no mention of them in your book, so I'll just skip it. This is the point the line is passing through. This is the cosines of direction cosines of the parallel vector that you don't have to know. I'll just explain how to find this. All right.
Yes, sir.
Okay. Now suppose they have given you a question. A line has a vector equation r minus 1, 2, -1. Okay. And they've asked you show that the Cartesian equation of the line can be written as x minus 1 upon L equals to y minus 2 upon m equals to z plus 1 upon n, where L, m, and r integers to be found. They ask you to solve this. All right.
Yes, sir.
Okay. Now, can you do this? Can I replace r as x, y, z? right?
Yes, sir.
So subtracting these two matrices, can I write x minus 1 I cap plus y minus 2 j cap plus z plus 1 k cap cross, this is 4 minus 3 2, 4 I cap minus 3 j cap plus 2 k cap equals to 0. Can we say this?
Yes, sir.
And now see, the cross multiplication of two vectors is 0. That means they are parallel vectors, right? Collinear vectors. Cross product is 0. That means they are parallel vectors, right? So can I write like this? X minus 1 I plus y minus 2 j plus z plus 1 k equals to some lambda times 4i minus 3j plus 2k. Can I write like this?
Yes, sir.
All right. Now you can compare these two quantities, right? See, the I quantity and I quantity. X minus 1 equals to 4 lambda, y minus 2 equals to minus 3 lambda, z plus 1 equals to 2 lambda. I can write like this, right? All right. I just compared the I quantities, j quantities, and k quantities, right?
Yes, sir.
So here I can write like this: y minus 2 upon minus 3 equals to lambda, upon 2 equals to lambda. I can also write like this, right?
You're replacing the ijk with the other values, right?
Yeah, I'm not replacing, I'm just comparing. The coefficient of I here is x minus 1, here is 4 lambda. So they must be equal. If two vectors are equal on other sides, that means the coefficient of I are equal, right? I just compared them. This is called comparing both sides. See,
Okay, sir.
if I plus bj plus ck equals to li plus mj plus nk, suppose if two vectors are given like this, that means the coefficient of I here, a must be equals to l, right? If two vectors are equal like this, right?
Yes, sir.
That is what I did here. All right. So now I can write like this: this equals to lambda, this equals to lambda, this equals to lambda. Now I can say if all the quantities here are equal to lambda, that means all quantities are equal. I can write like that also. So that means x minus 1 upon 4 equals to minus 2 upon minus 3 equals to z plus 1 by 2. Can I write like this also?
Yes, sir.
So this means that L, M, N value have this, right? You can see the question. They asked you to find L, M, and N. So this is L, M, and N. And they said you can write like this also. So yes, we can write like this also. This is the Cartesian format of a line. All right.
Yes, sir.
Are you absolutely clear?
So the bottom values are LMN.
Yeah, these are L, M, and N. All right.
Yes, sir.
Now let's solve. Now can you find Cartesian product, Cartesian form, right? You can find like this, no issue.
Yes, sir.
Okay, write down the question, solve that. Find the equation of the line in the form r cross b equals to a cross b, which passes through the points p and q, where p equals to p 3 1 minus 2 and q is minus 2 3 5. Okay, you have to find the equation of the line in the form r cross b equals to a cross b. I'll give you a few minutes.
So what is written beside the equation P and Q?
Yeah, p and q are points the line is passing through. All right.
Yes, sir.
Okay.
So when I do R times B, is it like R plus B?
No. You have to
Because
R
I'm getting
cross.
lambda as minus 2x,
You don't need to
3y.
find lambda in here, right? See, this is the formula you have to use. Leave R as it is and this side as it is. You just have to find A cross B here. This is the formula you need to use. You cannot find R here, right? R is the variable. You have to put. See, when you write equation of a line like this, you don't find the value of x and y, right? They are left as it is because they are the variable that make the line, right?
Yes, sir.
The same way, R here is the position vector of the point that moves along the line, which makes up the line. All right, you cannot find the value of R. R is the x and y here, like this. You just have to find B and leave B like this in cross product equals to A cross B. You have to find A cross B here. You have to find A first and B first, then cross multiply them. All right.
Yes, sir. Forty-one.
What is the answer of what is 41?
I got 11i plus 19j plus 11k.
Okay, so the see this is vector multiplication, right? So you will have to leave the answer as a vector quantity. So the answer would be R cross. What did you take the A? Sorry, B. What is the answer of B?
B is q.
You took this as B. No. You cannot take this as B because B is the line parallel to. So you have to subtract this from this. All right. You have to find PQ, and to find PQ, you have to do this Q minus P. That is minus 2, 3, 5, minus 3, 1, minus 2. All right. So the this will be minus 5, 2, 7. This will be B vector. All right.
Okay.
Yeah, because see, B vector is the parallel vector. So you have always have to, if 2 points are given, you have to subtract one point from the other. That would be the B vector. And A vector can be anything, P or Q, no issue. We solve again. Okay.
A times B is 7, 1, 11. Use
What did you take
A
as A?
as P.
P. All right, that can be your answer. You find out cross product, right?
Yes, sir.
All right. So I think you have an idea how to solve this. Do you have any doubts?
No, sir.
All right. So let's move forward. Equation of a plane.
Is this question in the book?
Yeah, this question is in the book. Example 18, page number 116 of the book. All right, not PDF. Page number 116, example 18. All right.
Yes, sir.
Okay. Let's equation of plane. In vector form, the equation is very easy. R dot n equals to P. In Cartesian form also, ax plus by plus cz plus d equals to 0. This is the vector form. This is the Cartesian form. Please write it. I'll explain what those quantities are. Okay. Here n is the
Yes, sir.
vector perpendicular to the plane, and P is, you get it, A cross n, A dot n,
Yes, sir.
and P equals to A dot n. All right. So the equation of the plane can also be written as this, where n is the perpendicular vector. All right. A is a position on the plane, position of a point on the plane. All right.
So what have you written? Position of a plane.
Position
Position of
of
a
a point.
point on the plane.
Yeah. A is the position of a point on the plane. All right. There is a plane. If this is a point, then A is the position of this point in vector form, and n is the perpendicular vector. All right. So to find the equation of plane, you need two things: a point on the plane and a vector perpendicular to the plane. All right. And this is very easy because all you can see is dot products. So you know how to find dot products very easily. All right. Let's do a question. Have you written it down?
Yes, sir.
Okay. You can write down the question. The point A with position vector 2i plus 3j minus 5k lies in an plane. All right. So point is given to you. The vector 3i plus j minus k is perpendicular to the plane. Find equation of the plane in vector form or scale. See, the thing I'm calling as vector form is actually scalar form. All right, but we write it in as vector, so I'm saying that as vector form. This is scalar form and this is Cartesian form. To find, shall I solve this first?
Yes, sir.
Okay. So here A is given as 2i plus 3j minus 5k. Of the question here, and n vector is given as. Can you tell me what is n vector here?
Can you see the question?
Here is the question. This is the n vector, right? 3i plus j minus k, because this is perpendicular to the plane, right?
Yes, sir.
Okay, so 3i plus j minus k. We know the equation of the plane as r minus a dot n equals to 0. Just substitute r minus 2i plus 3j minus 5k dot n is 3i plus j minus k equals to 0. You can open the brackets. So r dot 3i plus j minus k equals to dot product of these two. So 6 plus 3 plus 5, right? So this will be your answer in this form. All right. What scalar form?
So how did I get A?
A, the see, it was already given. Let me just go back. A is a position of a
No, not
point.
this A. It was R dot A, right?
No,
We
no.
multiplied A with N.
Yeah. See, I opened this bracket. This is r dot n. I have written minus a dot n, and I took this a dot n to other side. So this dot this. So 3 into 2, 6. 3 into 1, 3. Minus 5 into minus 1, 5. You know how to find dot product, right? This
Yes, sir.
dot this.
Can you rewrite
Yeah.
this equation in a straight line?
Okay. I'll just erase this and oh, you want me to rewrite this equation in straight line? This.
The second last one.
Okay. This is r minus a vector is 2i plus 3j minus 5k dot n vector is 3i plus j minus k equals to 0. Now I distributed them, open the brackets. So I'll have r dot 3i plus j minus k minus 2i plus 3j minus 5k dot 3i plus j minus k equals to 0. All right. Is this a step clear?
Yes, sir. I'll write it down.
Yeah. Now leave this as it is, but this is 14 if you find dot product, right? So the answer is r dot 3i plus j minus k minus 14 equals to 0. This will be your answer. All right. All right.
Yes, sir.
Okay. So now they have asked in the second part, find the equation of this plane in Cartesian form. So Cartesian form is very easy. Just replace r as xi plus yj plus zk. All right. Always replace this whenever they ask you to find the answer in Cartesian form. All right. So we had r dot 3i plus j minus k. So xi plus yj plus zk into 3i plus j minus k, right? Yes, and this was equals to 14, right? I just replaced the value of r as this Cartesian form. All right.
Yes, sir.
Now find the dot product here also. This is 3x plus y minus z equals to 14, and this will be your equation of plane in Cartesian. You can take this 14 to this side also, no issue. All right.
Yes, sir.
So this is how you find the equation of plane in Cartesian and scalar form. All right.
So what have you written for R? Is that 4i or ni?
xi xi.
Sorry.
In Cartesian form, we write the answer as x y z form. All right.
So can you
All
go
right.
back to the previous page?
Yeah. This is the answer we got in vector form or scalar form. I just replace the value of r as xi plus yj plus zk, and then found out the dot product. This is the same answer we had before. This is r, right? R dot this equals to 14. We had got to that 2 minutes back, right?
Yes, sir.
I just replace the value of r with this. Okay.
Can you go back to the previous page?
Didn't you write this down?
Writing the bottom part.
Okay.
So R is in bracket at the end.
No, this is simple r. R dot this minus 14. I just circled it to show you I replaced r. Okay.
Yes, sir.
Okay. So plane is also finished. Rest will do. Let me just give you a question also. In the form, you can write find in the form r dot n equals to p equation of the plane that passes through the point with position vector a and perpendicular to vector n. Okay, they've given you a equals to, this is exercise 5e, question number 1, a part. You have, if you have the book, you read the question and solve, please tell me the answer of a part. All right.
Yes, sir.
Okay.
R dot equation n equals to 0.
Wait a second. R dot equation n equals to
0.
0. So got this 2 minus 1 minus 1. Yeah, right, 0. And can you find the answer in Cartesian form also?
No, sir. I don't know.
Just replace R as xi plus yj plus zk. Replace here R as this quantity and find the dot product. You will have the answer in Cartesian form. All right.
It's going to be like x plus 2, right? Not 2x.
No, it will
It's
be
not.
2x because we are doing dot product, right? So xi plus yj plus zk. This is dot product. All right. This was r dot n, right? So you have this dot this. So in dot product you have to 2x plus y plus z equals to 0. This will be your answer. All right.
Yes, sir.
Now are we clear about this?
Yes, sir.
Okay. So in the next class we'll finish, and what chapter shall we start after that?
Chapter 2.
Chapter 2. You told me you know about chapter 1, right?
Yes, sir.
But we'll revise no matter what. Okay. So we'll do chapter 2. All right. In the next class, few things are left in vectors. Please revise this.
Yes.
Learn how
So I
to
only
deal with
have 3 classes left with you.
3 classes. Okay. Okay. No problem. We'll finish this. All right.
Yes, sir.
Okay. See you in the next class.
Thank you, sir. Bye.